Hello friends, today we will start with Unit 7, that is Mathematical Logic. Mathematical Logic. So introduction. In this unit we will discuss about one of the oldest branches of mathematics, which is known as logic. Logic is considered as science of reasoning. The field of logic ranges from core topics such as study of fallacies, paradoxes to the specialized analysis of reasoning using probability. What is logic? A statement is defined as a declarative sentence which is either true or false, but not both at a time. The statement, what is statement? Statement, okay. It is either true or false, okay, but not both at a time, okay. It is also known as proposition or atomic statement. This is also called as proposition. Okay, for example, the earth rotates around the sun. This sentence is declarative as it is giving us some information. It is true statement, hence it is logical statement or a proposition. Second example, it is not raining today. This sentence is also giving some information. It is either true or false, but of course not both at any particular time. Hence it is a statement. Give me that book. Give me that book. This sentence is not giving any information. Also, we cannot decide whether it is true or false. Hence, it is not a statement. So, next we will see truth value of the statement. The truthness or falsity of the statement is known as truth value of the statement. If the statement is true, we say that its truth value is true, denoted it by the letter T or by the number as 1. If the statement is true, then its truth value will be 2 or 1. If the statement is false, then it is denoted value will be F or 0. Okay. Consider the following sentence: the earth rotates around the sun. This statement is true, hence it is logical statement which has truth value will be P or 1. The positive divisors of 10 are 1, 2, 5 and 10 only. This statement is true, so it has truth value is true. So truth value of the statement. Okay. Logical connectives. Okay. Logical connectives, there are different types of logical statements. One is, first we will see the simple statement. A logical statement in which no connective is used. It's called a simple statement or a proposition or an atomic statement. Generally, small case letters are used to denote simple statements. Okay. Simple statements. In simple statements, we will see simple statement. statement will be Q 2 plus 7 equals to 10. This is the simple statement, or London is in England. 21 is a multiple of 9. This is simple statement. So we will see next as a compound statement. Compound statement. So Q is 2 plus 7 equals to 10, or 1 is prime number. So what is simple statement? A logical statement in which no connective is used is called a simple statement. Okay, and in compound statement, if a statement is formed by joining two or more simple statements. So in compound statements, when we use the two or more simple statements using logical connectives. Logical connective, this is the logical connective or and, okay. Then it is called as compound statement. What we have seen, simple statement and compound statement. Next, types of compound statements. So we will see negation. Negation. What is negation in types of compound statement? Negation is a compound statement in which the word not is the connective used, where not connective is used in negation. We always use negations of the sentences to indicate exactly opposite meaning. Okay. When P is a simple statement, here P is a simple statement, then the statement not P. P is a simple statement and not P is a negation of P. It is denoted symbolically as this. So, what will be the table for P? Negation P. This is P and this is negation P. Here, when the value of the statement is true, then negation P will be false. And when the P value will be F, then negation of P will be true. That is T. Okay, this is table for negation. Okay, this is P is the simple statement and negation P is the its opposite, negation P. Okay. Here, when 2 is not a rational number, 2 is a rational number, opposite meaning. These are some examples of the negation. Next, we will see conjunction. Okay. Conjunction. In conjunction, so conjunction. Okay. In conjunction is a compound statement in which connective used is the word and. We use the and in conjunction. In negation, we use not word. Okay. Suppose P and Q are any two statements. The conjunction of P and Q is defined as the statement P and Q. It is denoted symbolically as P conjunction Q. This is conjunction symbol. Okay, P, Sunday is a holiday. Every day I study for at least 4 hours. Okay. So P conjunction Q will, Sunday is a holiday and every day I study for at least 4 hours. So it is connected using word and. Okay. We will see the truth table for conjunction is P and Q is given, and what P conjunction B Q. So we will find out P conjunction Q. Okay. When the value of P is true, value of F is false, then P conjunction Q will be true. Here, when value of P is T and Q, this is true. When both are true, the P and P and P is truth value and Q's truth value is T, then P conjunction Q will be T. If P's value is T and Q's value is F, then P conjunction Q will be F. Okay. If P's value is F and Q's value is also T, then its value P conjunction Q will be F, and P's value is F and Q's value is also F, then P conjunction Q will be F. Okay, these are the conjunction table. Disjunction where you use the connective word as or, it is denoted as P disjunctions Q, right? The truth table for disjunction is P, Q and P disjunction Q. If the both are T, if one is T and one is F and one is F and second is T, or both are F, then it gives value as T gives T, then P disjunctions Q, it gives T. This also gives T, and third one is also T, and this is F. Okay, this is disjunction to table of disjunction. So P, when the value of statement value is true of statement P, and statement for Q, the value is T, then P disjunction Q will be is T. Okay. Conditional statement or implication. It is compound statement in which we combine two statements by the phrase if or then or implies that. Okay. Conditional statement in conditional statement it is denoted by if and then. If and then or implies that. Okay, this gives us a new statement. Suppose P and Q are two statements, then the compound statement if P then Q. How you will denote this? If P then Q, or it is conditional statement. We denote this conditional statement symbolically as P to Q. Okay, P only if P. Okay, the two simple statements are P, the student has a quest for knowledge, and the Q statement will, the student will take up new course. Then the conditional statement is if the student has a quest for knowledge, then he will take up a new courses. Suppose two simple statements P 3 plus 5 equals to 9 and Q is 5 is even number, then the conditional statement is 5 is even number if 3 plus 5 equals to 9. A conditional statement is a false only when hypothesis P is true, but the conclusion Q is false. It is true for all the remaining combinations of the truth value of P and Q. Therefore, the truth value of conditional statement is. Okay. Now we will see the table for conditional statement. Conditional statement. Here we will see the P, Q, P conditional Q. Okay. So when this value is true, this value is true, then P conditional Q will be true. Then this statement is true, this statement is false. Then it gives F. Then this is F, this is P. Then it gives true value. If it is false, and this is also false, then it gives 3. So this is conditional statement. In biconditional statement or double implication. First we have seen the implication, here it is double implication. So it is denoted by in biconditional. Next is biconditional statement or double implication. So in biconditional statement, it is denoted as P double arrow Q. This is biconditional. So in biconditional, what will be the table? P, Q, P biconditional Q. Okay. P, T, T, F, F, T, F, and F. Then this is T, F, F, and T. This gives the biconditional result. So in next lecture, we will see the logical equivalence statement. So what is logical equivalence statement? So we will check it. So logical equivalent statements. Suppose that P and Q are two compound statements made up of the same atomic statements P1, P2, Pn. We say that P and Q are logically equivalent if for every combination of the truth values of the atomic statement P1, P2, Pn, the truth values of P and Q are identical. So we will take one example. Like P conditional Q is equivalent to not P and Q conjunction, right? So we will check whether it is equivalent. So How to solve this? We have to construct the truth table. So this is P, this is Q, this is P, conditional Q, then negation of P and negation of P conjunction Q. Okay, so we will check true, true, false, and false. In Q, this is true, this is false, this is true, and this is also false. So P conditional Q, it gives as we have seen this. Okay, T to T gives T, T to F gives F. This is T and this is also T. Negation of P is F, F, T, and T. Okay. So negation of P conjunction Q. It gives as T, F, T, T. So here you can repair the table. First is we have seen TF double T, right? TF double T for conditional statement. Here we have taken this TF double T after negation F F T T. Okay. So what will be the value for T to F to T? Here you can see solving. So how you write this? So negation, this is, here you can solve this as F, F, T, and T. And Q's value is T, F, T, F. Okay. So in disjunction, so here you can see the table for disjunction. For T to T is T, T to F is T, F to T is T, and F to F is F. So when there is one T, so we have to T, else it is F. So in this, it gives as so F T, then it is T, here it is F, here it is T, and this is also T. So this is the same result as we get here. This is negation P and this is Q. Okay. So this is the equivalence. We have checked the equivalent statements. These two statements are equivalent. Next is logical identities, double negation law. Logical identities, double negation law. When two negations are applied, then it is equivalent to P. De Morgan law, in De Morgan law, when negation is applied to this, then it is equivalent to this. This is called as De Morgan law. Commutative law, in commutative law, this is equal to Q, this. Okay. Associative law, P, Q, this is equal to R, P, Q, and R. Okay. This is it. So please do solve this at your home. Try to solve. So this is associative law. Now we will see the distributive law. What is distributive law? So when it is P, Q, and R, okay? P, Q, and R, okay? This is equals to P, Q, and PR. Okay, this equation is equal to this. This is distributive law. In conditional, when P conditional Q is given, then negation of Q is conditional to negation of P. Or P biconditional Q is given, then P conditional Q and disjunction Q biconditional P, Q conditional P. Okay. Next is tautology and contradiction. Converse, inverse, and contrapositive. There are different converse of conditional statements. So we will see converse of conditional statement, that is P conditional Q, is the conditional statement Q conditional P. This is converse. Okay. Then inverse P conditional Q. Inverse will be negation of Q, negation of P conditional to negation of Q. This is inverse. And contrapositive. Okay. And contrapositive P conditional Q negation of P. This is contrapositive. So in next chapter we will see detailed problems on this. Converse, inverse, contrapositive, what is logical equivalent statement, logical identities. We will study problems in detail. Now we will end this meeting. Thank you everyone.